In this tutorial, we will show how to conduct a one-sample t-test using Excel. For most t-tests usually available to test means, Excel has pre-programmed facilities in the Data Analysis tool pack. You find the Data Analysis tool pack in the Data ribbon. If your installation of Excel doesn't show the Data Analysis tool pack in the Data ribbon, you can activate it by going into More Commands, Add-ins, Manage Excel Add-ins, and checking the Analysis tool pack. Once you have the Data Analysis tool pack in your Data ribbon, you can use it. If you check now the Data Analysis toolpack, you can see that you have t-tests for paired samples testing, independent samples testing assuming equal or unequal variances, and z-testing for two samples. You don't have an option for testing one sample t-test. So the options that you have are the following. You can either type in the basic formula or use one of the built-in facilities using a little trick that I will show within this tutorial. So we have the following problem. Assuming the company Adventure Sports orders bungee cords with an average stretch of not more than 18 meters. So we will try to verify if they got the right shipment. So the hypothesis, first we need to set the hypothesis. Hypothesis is about the mean. They ordered a shipment of average length of 18, so that's the expected state. Since that is the expected state, they put this in the null hypothesis. They expect them not to be more than 18 meters, so they can be less. They should just not be more than that. So the wrong shipment will be the one that stretches above 18 meters. So in order to verify whether they got the right shipment, we will try to prove that the mean is above 18. We'll do this using a one-sample t-test, this formula. So we are trying to find the area on the right-hand side from this t-statistic. So as you can see from the formula, in order to get this t-statistic, what we need is the x-bar, which is already calculated here. You can see using the formula average for the data that is given here. We need the hypothesized mean, given in the hypothesis here, meaning 18. We need the standard deviations, which we have, and we need the sample size, which we also have already prepared. So our t-value, just type in the formula, t will be the computed mean minus the hypothesized one, 18, divided by standard deviation divided by square root, SQRT, of the sample size. We get our t-value. So essentially this t-value is the critical t-value given here. Now we need this right-hand size significance. In most computer software you will find this under p-value. P-values can be obtained via cumulative distribution function for the t-distribution. However, the cumulative distribution function will always give you the left-hand side. We need the right-hand side. So what we need to apply is the knowledge that the area under the whole curve equals 1. Since the cumulative distribution function will give us the left-hand side, we need the right-hand side. The right-hand side will be 1 minus the left-hand side. So the p-value will be 1 minus t dot t for this value of t, then the second field is degrees of freedom. For one sample t-testing, the degrees of freedom is always sample size minus 1. So this will be sample size minus 1. And we will enter true or simply 1 here, since we need the area under the curve and not the height of the curve above the axis. So the p-value that we got, one-tailed p-value, is 0.0566 or 5.66%. 5.66% is above the usual threshold of 5%. So in this case, we could conclude that there is not enough evidence to reject the null hypothesis. The other two methods for doing this same test, but using data analysis toolpack, involve tricking the computer into thinking it has two samples. The two samples can be either paired or independent. So we will assume we have another sample of the assumed value. So the assumed value in our case is 18. So we type in 18 here and then just autofill this. Once we've prepared this, we can run either the paired samples t-test or independent samples t-test. I will show both in the continuation of this tutorial. So using data analysis toolpack, I will first choose t-test for paired samples. I will input the actual variable as the first variable and the assumed values as the second variable. Since I've chosen also the top row, which simply has the names for the variable and the assumed values, I will check labels here. I will also choose to put the results in the same sheet, namely I will choose a cell here, which will be the top left cell for the results. If I now press OK, I get the results. Obviously the assumed variable has zero variance, therefore also the correlation between the two is not computed. But what's important for us is that we got the same t-statistics as using the manual formula, and we get the same one-tailed p-value or exact significance. Instead of doing this, we can also choose one of the independent samples t-testing. However, the only one that we can use is the one assuming unequal variances, since by default our artificial variable will always have a variance of 0. So we will select t-test using assuming unequal variances, and we select the same. For one variable we select our actual variable, for the second one the constant including the assumed value, check the labels, output, I'll just override this output, and we get basically the same results as we had before. This concludes this short tutorial.